Hi, this is Dr. John Bergduff. So for a little while now, you've been studying about synthetic division. And it seems like you use synthetic division all over the place. It gets used for this and then that, and every time we turn around, we're doing synthetic division again. And also, sometimes we change signs on numbers, and sometimes we leave the numbers the same. And so there's a lot that can kind of get all mixed up in your head after you've looked at synthetic division for a while. This video is designed to be a summary. So having studied the remainder theorem, the factor theorem, the rational zero theorem, and all those things, just to tie it all up, I want to do a quick video talking about and summarizing some of the things that you can do with synthetic division. So what can you do with synthetic division? Well, one thing you can do with synthetic division is you can do division. You can divide two polynomial functions. So if you're using synthetic division to divide two polynomial functions, the divisor does have to have the form x minus k, and that does allow for a positive sign because that just means k is negative. And when you write this synthetic division, when you're dividing, you change the sign of the number that's in the divisor. So if this says we're dividing by x plus 2, I'm going to put a negative 2. Under the division symbol, I'll put the coefficients of the dividend, and I'll keep an eye out for any missing terms. I see 1x cubed, 5x squared. I don't have an x term, so I'll put a 0 and a minus 3. And then we run through the synthetic division process, which has almost become something we can do in our sleep now. We copy the 1. We multiply the 1 by the negative 2 from the divisor. And so that would give me a negative 2. Then we add down the column. That gives me a 3. Multiply up. Again, multiplying by the negative 2 from the divisor. Negative 2 times 3 is negative 6. And then add down the column. So the pattern is add down, multiply up. We have one more thing we're going to multiply. Negative 6 times negative 12 gives me negative 2 times negative 6 gives me a positive 12. I'll get that right in a minute. And then adding down the column, we get a 9. So let me say it again. Negative 2 times negative 6 gives me a positive 12. Add down the column, you get a 9. When you're doing a division, the final number on the bottom row is going to be your remainder. And the rest of the bottom row will be the coefficients of the quotient. And we express the result as the quotient plus the remainder over the divisor. The degree of the quotient is always 1 less than the degree of the dividend, so I started with an x cubed. That means I'm going to end up with an x squared. So to be precise, it would be x squared plus 3x minus 6. That's the quotient plus the remainder over the divisor. And we go back to the original divisor up here. So one thing you can do with synthetic division is you can divide. But that's not all. You can also use synthetic division to find function values of polynomial functions. Now in this case, the number you put in the divisor position is exactly the number that you want to substitute. You don't change the signs here. On division, you change the sign. On finding function values, you do not. So I'm going to literally write a 3, and then underneath the division sign, the coefficients of the dividend. And I notice that I am missing an x squared term this time, so I'll have to put a 0. And then I run through the synthetic division again. The 1 gets copied down. 3 from the divisor position gets multiplied by 1. That gives me a 3. Multiply up, add down. Multiply up, 3 times 0 is 0. Add down, still 0. 3 times 0 is 0. More zeros. Add down. 3 times 4 is 12. And 12 minus 7 is 5. And when you're using synthetic division to find function values by the remainder theorem, the thing you're interested in is the remainder, and that's the function value that you're looking for. So f of 3 is equal to 5. So you can divide two polynomials, you can find values of polynomial functions. Very closely related to number 2, you can check for zeros of a polynomial function. So asking the question, is 5 a zero of the polynomial, is really just saying that if you substitute for 5, do you get 0? So this will be just like number 2. And again, the number you substitute, you do not change its sign. You are just substituting a value, so you put a 5 there, don't change its sign. Then put the coefficients of the dividend underneath, or the function itself, 1, minus 8, 5, and 50. And you run through the synthetic division again. The 1 you copy down, 5 times 1 is 5, negative 8 plus 5 is negative 3, 5 times negative 3 is negative 15, 5 plus negative 15 gives me negative 10, 5 times negative 10 gives me negative 50. 50 minus 50 gives you a 0. That's exactly what you're hoping for. This is telling me that the function value is 0. So is 5 a 0 of the polynomial function? The answer is yes. So you can check for zeros of polynomial functions. Divide polynomials, find function values, check for zeros. One more thing, you can use synthetic division to factor polynomials and find all the zeros. And that's what I'd like to do with this function. Now, if you notice, this function here, just because I'm getting a little lazy, is the exact same one on the previous example. So if I start with the concept of finding all zeros, I already know what one of them is. I'm going to just check it out again. If you don't know, this is where the rational zero theorem would come in to give you some choices to try, and you would pick from that list and just see whether any of them are zeros. But I believe we're pretty sure that the 5 is going to be a 0. Let's run through it again and see what else we're going to learn from this. Again, the coefficients, 1, minus 8, 5, and 50. Run through the synthetic division one more time. The 1 gets copied. 5 times 1 is 5. Minus 8 plus 5 is negative 3. 5 times negative 3 is negative 15. 5 minus 15 is negative 10. 5 times negative 10 is negative 50. 0. Now, so this verifies that 5 is a 0. But if 5 is a 0, that also tells me that x minus 5 is a factor by the factor theorem. So what I get as a bonus here is that I can begin to factor this polynomial. One of the factors, again, is going to be x minus 5. If 5 is a 0, x minus 5 is a factor. What would that be multiplied by? Well, it's the polynomial that you have left as the quotient in the synthetic division. So this would begin to factor as x minus 5 times x squared minus 3x minus 10. If this were a polynomial of degree 3 or more, you might go back to your rational zeros theorem to hunt for something else to check for. But at some point, you should be able to get this to a quadratic expression and then factor it in the normal way. Or normal, I don't know what's normal, but the usual way. So I can see right here that this does indeed factor as x minus 5 times x plus 2. And if I want to, I could actually state that as x minus 5 squared times x plus 2. I have accomplished this task. I have factored the polynomial. Now, have I found all zeros? Well, really, I've done that too, because the zeros of the polynomial are found by setting the factors equal to 0. So if I go to another page, the zeros of this polynomial will be found by setting x minus 5 equal to 0 and x plus 2 equals 0. Now, we already knew that 5 was one of the zeros. Negative 2 is another one. But looking back at the previous page and seeing that the x minus 5 is squared, what this is really saying is that the 0 that is 5 is duplicated. It appears twice. So if I were going to make a list of all the zeros, I might say that one of the zeros is 5 with a multiplicity of 2. Simply means that it repeats a second time, and the other zero is negative 2. So I hope that kind of ties everything together for you. 4 things you can do with synthetic division: when you change the sign, when you don't. I hope you'll enjoy it very much. It's a great tool that you'll be able to use all through mathematics. So even though we're going to be leaving it for a little while in this course, you're likely to see it again.